Hello everyone, this is Prashanth. Let's continue with the last lecture. So we are in controlling hardware and sensors. We are in the topic at that topic. In the previous lecture, just I have completed hardware components like connecting LED, buzzer, high switching devices, relays. Like that, just we have completed these are the some hardware components with sensors completed in the last lecture. So what are the specifications, how how to connect to connecting, how make the connections on the breadboard, how the write code to dump the microcontroller, like that we some different specifications, applications, real-time examples. So like that we have discussed up to the last lecture. Now we move entering into the another hardware control device, that is unipolar and controlling of unipolar and bipolar devices. What is the meaning of unipolar and bipolar? Just we discussed in the next. So here, before we entering into actual content of the lecture, what are the objectives? What are the outcomes for stepper motor? Unipolar versus bipolar, just like what are the objective, both unipolar and bipolar stepper motors share the main objective of providing precise controlled angular rotations. They achieve these converting digital electrical pulses into discrete steps of rotation. So actually unipolar and bipolar stepper motors here, the actual content here, these are the objective. Next, coming to the outcomes for unipolar devices, it is simpler control circuits. It is easier to drive due to simplex winding configuration, that is the simpler control circuits, and lower cost, less complex design often leads to a lower power point, that is the second one, that is lower cost. Next, to lower torque. So lower torque is nothing but uses only half of the coil winding at a time, resulting in a lower torque output, like that. Next, last but one, lower efficiency also. It wastes energy by not fully utilizing the windings. So that is the last one. Lower speed, the torque limitations affect the achievable speeds. Sometimes it may happen, it is not a regular process. So these are the outcomes under unipolar: simpler control circuits, lower cost, lower torque, lower efficiency, and lower speed. So next, the outcomes based on the bipolar, it is higher torque. Almost all properties are higher torque, higher efficiency, higher speed, more complex control circuits, and higher cost. Compared with the unipolar, just it is little bit high, that is higher torque. It is nothing but fully utilization of windings leads to higher torque output. That is the essential thing in the connecting the IoT device. And the higher efficiency, the more efficient use of power for better performance also, and higher speed. Greater torque allows for achieving higher speed, and more complex control circuits require H-bridge or similar circuit to reserve current. And higher cost, more complex design often leads to a higher price count. So these are the some specializations of objectives, outcomes of bipolar stepper motors. Next, just we move entering into the sensors in just IoT. Nothing but here it refers to the physical aspect of the Internet of Things, where physical objects are integrated with the digital world. So sensors play a crucial role in the this by collecting data from physical environment that we already know. Here are some examples for sensors commonly used in IoT: light sensors and temperature sensor. Under light sensor, just what is the objective, what is the outcome based on the light sensor? The objective is measure light intensity. Outcome enables applications like automatic lighting control, occupancy detection, and plant monitoring system. So in order to develop this type of automatic lighting control, occupancy detection system, or plant monitoring system, to that just we use light sensor. That is the it will give the better outcome. And temperature sensor, nothing but thermistor. So the objective is measure the temperature, in order to measure the temperature from either room temperature, body temperature, whatever the temperature they need, by using temperature sensor, that is thermistor. Outcome, it enables the applications like environmental monitoring, process control, and thermal management system. So these are the outcomes of just where we are using, by using that thermistor, just we can develop the this environmental monitoring system, process control system, and thermal management system, like that. So these are the some sensors. And remaining voltage sensors, what are the objective of voltage sensor? It measures the electrical voltage, how much voltage we are going to give, how much voltage we are going to get at the output as input, like that. Outcomes, it enables the applications like power monitoring system, battery level detection system, and fault diagnosis in the circuits. So this is about the voltage sensor. So by integrating these sensors with the stepper motors and other actuators, its systems can achieve a high level of automation and control in various physical environments. So this is the actual sensors available in the Internet of Things. And next, just we move entering into the unipolar and bipolar stepper motor sensors. Here, in this principle of IoT, stepper motors and various sensors play vital role in achieving precise positioning and control. Here, breakdown of how they work and are used. So this is the just introduction point. And stepper motors, unlike DC motors, then spin continuously. Stepper motors rotate in discrete step when electrical pulses are applied. So just when we are applying electrical pulses are applied input signal, the stepper motor continuously spin and rotate in discrete steps, like that. This precise step-by-step movement makes them ideal for applications requiring controlled positioning, common in IoT projects. So this is the actual things with stepper motors. And remaining unipolar and bipolar stepper motor sensors. The types of stepper motors here: unipolar stepper motor and bipolar stepper motor. So what is the main difference? What is the specifications of unipolar and bipolar sensor here? Unipolar stepper motor, it is just it having typically simple design with fewer wires only. Just we to build it requires only few wires and requires a simpler driver circuit, offers less torque compared to bipolar motors, and current flows in one direction through the coils for movement. So these are the four input points regarding unipolar stepper motor. When go to the bipolar stepper motor, it more complex design with more wires, typically 4 to 8 wires. So just connecting wires, nothing but 4 to wires are required. It requires only 4. Requires a more complex driver circuit for purpose precise current control in both directions, both input and output directions. Offers high torque compared to unipolar motors. It is offers high torque compared to unipolar stepper motor, and current can be reversed in to the coils to achieve rotation in the both directions. So these are the some points regarding bipolar stepper motor, or differences between unipolar stepper motor and bipolar stepper transformer in terms of different specification, like how many it needs wires, requires simple driver circuit, torque in terms of rotation in both directions. So these are the some types of two types of stepper motors. So remaining controlling stepper motors in IoT here, these are the some specifications here. Microcontroller send control signals to the stepper motor driver circuit. That is the first specification. Controlling stepper motors in IoT, how the stepper motors controlling based on the IoT. The signals specify the number of steps, direction, either clockwise direction or anti-clockwise direction, and sometimes the speed of rotation. Stepper motor driver circuits translate the current control signals into the appropriate sequence of electrical pulses. for the specific motor type, that is unipolar and bipolar stepper motors. And sensors in stepper motors control. What are the sensors? Sensors can be used in conjunction with the stepper motors to enhance control and functionality in IoT applications. That is the main purpose of just use specification to control and functionality in IoT applications. So limit switches. Here, these mechanical switches can be placed at the end of a travel range to direct when the motor has reached its maximum position, preventing over rotation and damage. So this is the about limit switches. Next, um, rotary encoders. So here these sensors provide feedback on the motor's shaft rotation. The microcontroller can use this information for precise positioning or closed loop control, ensuring the motor reaches the desired position accurately. So this is the rotary encoders type of sensors. And applications of stepper motors in IoT, we have different applications like 3D printers, CNC machine, camera control systems, pick and place machines. The first application, that is 3D. Stepper motors previously control the movement of the extruder head, laying down filament in a control pattern to create 3D objects. So that is 3D printers. The second one, CNC machine. CNC machine, it uses the to move cutting tools or the workpiece along with precise mass for computer control machining. That is the CNC machines. Next, camera control system. Stepper motors can be used to position security cameras or adjust to the zoom and focus of lenses. That is the camera control system. The last one, pick and place machines. In automated assembly lines, stepper motors precisely control robotics arms for picking and placing the components in IoT device. So these are the some applications of stepper motors in IoT: 3D printers, CNC machine, camera control systems, pick and place machines. So next, just we having some choosing the right step motor to develop the IoT applications. These are the specifications in order to choose the right stepper motor. The choice between the unipolar and bipolar depends on your project's requirement. That is okay. Unipolar motors are simpler to control, but less it offers less torque. So that is also one of the disadvantage, but it may ignore to develop in the IoT projects. Bipolar motors provide higher torque, more precise control, but require a more complex driver circuit. So that is the one of the right point. And consider factors: motor size, torque requirements, desired step resolution, project complexity when making your selection. So this is the fourth point to choose right stepper motor to develop the IoT project. Whether the unipolar or bipolar, just you choose unipolar. There is one disadvantage. If you choose bipolar, there is one of the disadvantage. So in order to overcome that, just we try to implement and possible things on IoT project. So that is the steps to choose. And learning resources. So here, what are the learning resources for these unipolar and bipolar stepper motor sensors? Search online for control step motors with Arduino. Just you can type in the Google or unipolar versus bipolar stepper motors. You will find the tutorials explain the concept, wiring diagrams, code example, and project ideas like that. Starter kits for microcontrollers sometimes include stepper motors and driver circuits, allowing you to experiment with stepper motor control in practical setting. So that is the second point. So in conclusion, summary, the understanding of stepper motor, how sensors can enhance their functionality. You can create IoT projects with precise positioning and control capabilities, operating doors to new applications and innovative design. So this is the just a summary of the unipolar and bipolar stepper motor sensors. Let's continue remaining sensor, that is light sensor here. uh, Light sensors, it are fundamental components of many IoT applications, allowing your devices to react and adapt to changes in ambient light. Here's how they work and how you can integrate them into your IoT project. That is the essential part. So the types of light sensors here, light dependent resistor, that is LDR, very very important one. Light dependent resistor, when the resistance decreases, the light intensity increases. When the light is increases fall on the particular device, the resistance may be decreased. The inversely proportional to the intensity of the light. The resistance are inversely proportional to the intensity of the light. They are inexpensive but may not offer a linear response across the entire light spectrum. So that is the LDR, light dependent resistor. Next one, photodiodes. These convert light energy into electrical current. They offer faster response time and better linearity than LDRs, but are generally more expensive. That is the photodiodes. And phototrans, these are the electronic devices also, nothing but electronic devices that may useful to develop the IoT projects. LDR, photodiode, phototransistor. In previous lecture, just we talk about the LED, buzzer, transistor, NPN, PNP transistor, like that. The all are the electronic components just we use it to develop the IoT projects like that. Phototransistor similar to photodiodes. They are light sensitive semiconductors that conduct current based on light intensity. They can be used as switches for analog light level measurement. So these are the some types of light sensors here. Next, ambient light sensor, using light sensors. Ambient light sensors here. These are integrated circuits that combine a light sensor while signal processing circuitry. They often provide a digital output professional to the light level, simplifying integration with the microcontroller. So this is the third light sensor, the ambient light sensor, that is LALS. Using light sensors in IoT, here automatic lighting control. In order to develop any IoT project, the initial thing is automatic lighting control. It can be used to turn on lights at desk and turn off them at dawn, saving energy. They can also be used to dim lights automatically based on ambient light levels. So this is the first using light sensors in IoT. The second one, smart agriculture. Light sensors can monitor light levels in greenhouse or growth chambers, helping to optimize plant growth conditions. That is the second one. And security systems. Light sensors can be used to detect movement or intrusion by identifying changes in light patterns. So that is the security system. Next one, display brightness control. Smartphones and other devices can adjust screen brightness based on ambient light for improved readability and battery efficiency. Display brightness and control. So these are the using light sensors in IoT. Next one, connecting light sensors to microcontroller to dump the program or to do the some internal operations here. The connection method depends on the specific type of sensor type. LDRs, light dependent resistors, typically requires a voltage divider circuit with a resistor to convert resistance changes into a voltage level readable by the microcontrollers, analog to digital converters, like that. The second, photodiodes and phototransistors may require additional circuitry depending on the application, that is current amplifiers. Second one, ALS, automatic have a simpler connection requiring only power and ground connections, and sometimes use I2C, inter-integrated circuit, or a serial programming interface communication protocol for data transfer. So these are the how the connecting lights to the microcontroller. So next one, programming for light sensor data. So here the microcontroller code reads the sensor data, analog voltage for LDRs, or digital values for ALS. Based on predefined thresholds and algorithms, the code can make decision to control others like lights, or sensor data to the cloud for further processing and visualization. So these are the 2 points regarding how programming for how to write the program for on microcontroller. So learning resources. Here just you can type light sensor with Arduino or type of light sensors for IoT. You will find tutorial explaining sensor types, connection methods, and code example and project ideas like that. Starter kits for microcontroller often include light sensors, allowing you to experiment with light detection and control in your IoT project. These are the learning resources of sensors used in IoT. By incorporating the sensors, you can add a layer of environmental awareness to your IoT projects, enabling them to interact with, adapt to their surroundings based on the light conditions. The last but one here, temperature sensor with thermistor in order to reading the temperature whatever just we use in room temperature or environmental temperature or industrial temperature whatever in the IoT the temperature sensors are essential monitoring and reacting changes in environmental temperature. Understanding of thermistor, so here the few points here. Thermistors are temperature sensitive resistors. Their resistance value changes significantly with the temperature variations. That is the important point regarding understanding of thermistors. The second one, they come in different types, packages, bead, disc or probe, suitable for various applications. That is the second one. Thermistors have a negative temperature coefficient, meaning their resistance decreases as the temperature increases. So these are the some points of understanding the thermistor. And using thermistors in IoT, we have different aspects using thermistors in IoT. Thermistors are used in various IoT projects to monitor the temperature in environmental monitoring system for homes, greenhouses, and industrial setting. Home, greenhouse, industrial settings, and wearable devices like smartwatches to track body temperature. That is the third point. And smart appliances like refrigerator or ovens for temperature control also. 3D printers also to monitor the extruder or bed temperature for optimal printing. So these are the using thermistors in IoT. This is the purpose. And connecting thermistors to microcontrollers. Thermistors by themselves don't provide a direct temperature reading. That is the first one. And they require a circuit to convert the resistance change into the voltage level readable by the microcontroller. So that is the second point. And the third point, the common method is the voltage divider circuit, which includes the thermistor and a fixed resistor. As the thermistor's resistance changes with the temperature, the voltage across it also be changes. So these are the using thermistors in IoT and connecting thermistors to microcontroller some points. And next is just we microcontroller code for thermistor here. In order to write the code for executing the internal operation, the microcontroller code reads the voltage from voltage divider circuit. It's analog to digital converter. That is the first one. The second one, based on the thermistor style or data sheet and a conversion question, the code calculates the actual temperature from the voltage reading. Next one, this temperature data can be used for various purposes like displaying temperature on LCD or sending it to the cloud for remote monitoring. Controlling other devices based on temperature thresholds. For example, turning on a fan if the temperature gets too high. So this is the microcontroller code to write the code for microcontroller for thermistor. Next one, calibration here. The part of calibration, thermistor behavior can vary slightly between different components. For high precision applications, consider calibrating the thermistor using a reference temperature source and a multimeter to ensure accurate temperature readings in your code. That is the calibration part. Learning resource. So the search for online. Just we can give the thermistor with Arduino or temperature sensor circuit for IoT. Just you can type in online. these two words, you will find tutorials explaining the theory, connection methods, code examples, and project ideas. So many more project ideas are not only with this. It can display many project ideas also. It will display. Based on that, we are going to design some other project also. It's for a microcontroller often include thermistors and resistors, allowing you to experiment with the temperature measurement and control in your IoT projects. By understanding the thermostat, these are these just to summary part. These are the unipolar and bipolar stepper motor sensor. Remaining continue with the next class. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.